Okay, so continuing with section 3.5, I'm just going to do an example. This is example 10 from my notes, so this is not in the book as far as I know. I might have stolen it from the book, so it might be an exercise somewhere in the book, probably an even one. But this is going to be kind of a tricky one, okay? So I'm going to go through this as carefully as possible. Um, and I wouldn't expect a lot of these on any tests, but you know, if I'm going to give you a challenging one, it might be something like this. But if you can handle the ones in the previous video, you should be okay. Um, so, so here's the example, right? We want the limit as x goes to negative infinity of 3x minus 2 over the square root of 2 times x squared plus 5. Okay. So, yeah. So first, let me just copy down the problem so we can see it a little more clearly here. We want the limit, sorry about that. The limit as x approaches negative infinity of 3x minus 2 all over the square root of 2x squared plus 5. Plus 5. Okay. So, yeah, so this is a little different because we didn't have square roots. Well, we did have simple examples like 1 over the square root of x, right? And yeah, since the numerator was just a constant, we can apply that theorem exactly here, but not in this case, right? Because the numerator is not a constant, right? So what we could do is say the same trick that we did in some of the previous examples. We can take the biggest power in the denominator and divide top and bottom by that, right? So let me set that up here. Give me a second. Sorry. X goes to negative infinity. I'm going to put in parentheses 3x minus 2 for the numerator. And in the denominator, you know, I could use a power of 1/2 here. I don't have to, but let's do it that way. So 2x squared plus 5 all raised to the power 1/2. Right? So what's the biggest power in the denominator? Well, if you're thinking x squared, that seems to be true, right? So you think our r is 2 here, but remember, you're also taking it to the power 1/2, right? So if I have x to the 2, and then I raise it to the power 1/2, well, that's just x to the 2 over 2, which is x to the 1. So we're not raising the denominator is not really a power of 2 here, because we're taking the square root of it, it behaves a lot more like x to the 1 rather than x to the 2. So yeah, so be careful. If you multiply top and bottom by 1 over x squared, it's not going to work out right. We just want 1 over x. So the square root of x squared. Okay, so yeah, so same trick that we did earlier, but now we can do the same thing here. We're going to distribute the 1 over x, right, like this. So we get 3x over x, which is just, well, okay, so I'll do this one more time. 3x over x minus 2 over x, right? Now, what about the denominator? So this is going to be a little tricky. I'm going to go back to the square root here. So I only wrote it as x to the 1/2 to illustrate that we're not doing x to the 2, but x to the 1 here. Okay, so now, so yeah, I'm just going to write it this way. 2x squared plus 5 all over x. Okay, and so that doesn't really seem to help at this point, right? We're going to have to simplify this further. And this is where it's going to get tricky. This is where we're going to have to deal with this negative infinity here, right? So as an aside, I'm going to try this, right? So I'm going to go over here, and I'm going to remind you of when you take the square root of x squared, you don't really just get x, because it depends on whether x is positive or negative, right? What you actually get is the absolute value of x, right? Which is, if you remember, x, if x is positive, or 0, right? And negative x if x is less than 0, right? So let's reverse this, right? If x is greater than or equal to 0, then x is really the same thing as the square root of x squared. On the other hand, if x is negative, negative x is the square root of x squared, or x is really the opposite of the square root of x squared. Okay, so that's what I'm going to do here. I'm going to take this x and change it to this. So why are we picking the bottom one and not the top one, not the plus? Well, remember, x is going to negative infinity here, right? Right? So if x is going to negative infinity, you can be sure all the x's are going to be less than 0, going to be negative. So that's why we need a negative sign here. Okay? So my next step is just to change this x to negative square root of x squared. So I'll do that down here. Hey, oh, while I'm at it, 3x over x is just 3 minus 2 over x. Okay. But now we're going to get, so the numerator of the denominator is still 2x squared plus 5. That didn't change anything yet. And now we have negative square root of x squared. That's an x. Okay. And so that negative, right, it's just a negative fraction here, right? Okay, so change that to a plus. That's a minus. And we have a positive divided by a negative, so that negative can actually come clear all the way in front of the limit. So this is just negative limit x goes to negative infinity of 3 minus 2 over x, and then all divided by, so what's this going to be, right? This is going to be the square root of 2x squared plus 5 divided by x squared, right? You can combine them all into a single square root. And we can even go further here, right? This is the square root of 2x squared divided by x squared plus 5 divided by x squared. Sorry, that's an x. And 2x squared over x squared is just 2. And then plus 5 over x squared. I think I'll leave that alone for now. Right. So we rewrote the denominator as the square root of 2 plus 5 over x squared. So, okay, so that was a lot of algebra. So let's just take a deep breath here and, look at where we've been here. So we're calculating this limit, and the first step is to figure out what to multiply top and bottom by, in this case 1 over x, right? And then, again, the tricky thing here is you have to realize that because you're going to negative infinity, we're not changing x to the square root of x squared, we're changing it to negative square root of x squared. Okay, so that's where we get this negative sign in front here, right? See that? Okay. And then we just did a lot of algebra here, and we simplified all of this to this form here. Right? Okay. Well, now we're in good shape, because now notice that we have constants in the numerator and x in the denominator. So by that same property from the last video, 2 over x, as x goes to infinity or negative infinity, either way, this has to approach 0. Likewise, in the denominator, this 5 over x squared, c over x to the r, so c is 5, r is 2, but either way, that approaches 0, right? So what's left over then, give me a second here, what's left over is negative, right? The negative is still in front here, right? So don't forget that. Limit, as x goes to negative infinity, of 3 minus 0 over the square root of 2 plus 0. But now there's no more x's, so this is just going to be the constant, 3 over square root of 2, right? But be careful, there's that negative in front, so it's actually negative 3 over the square root of 2. And that's our final answer, right? So that answers the original question. Oops, sorry. What is the limit as x goes to negative infinity of 3x minus 2 over square root of 2x squared plus 5? That's a mouthful. Well, now we have our answer, right? The answer is way down here, negative 3 over the square root of 2. Which, well, okay. Look, that I already told you many times that you can leave your answer with an irrational denominator. If you were to simplify this, you would get negative 3 square root of 2 over 2. And in fact, if the book has an answer key, the book would write it this way as well. But you know how to you know how to rationalize the denominator, I assume. Just be aware that on a test, I am not picky about that. You can write it either way at this point. So, yeah, I hope that helps. Again, this was a tricky problem. This I would say is a hard problem, especially because you have to wrap your head around this the absolute value of x and the square root of x squared, right? They're the same thing, but that means that x has to turn into this negative square root of x squared instead of a positive. And that's where the negative sign came from, right? That's why this is negative here, not positive. Because you're going to negative infinity, you get this negative sign. If we were going to positive infinity, hang on. Let's treat that as a separate example here. If we're going to say the limit as x goes to positive infinity of the exact same expression, 3x minus 2 over the square root of 2x squared plus 5. Well, I think rather than go through this whole thing again, I think we can say pretty easily that the only difference is that if you're going to positive infinity, then you're doing when x is greater than 0. In other words, you're changing x to the square root of x squared. Yeah, the square root of x squared. In other words, you're not going to get this negative sign here, right? So you're not going to have a negative sign. It's just going to be positive 3 over square root of 2, or if you rationalize the denominator, 3 square root of 2 over 2, right? So without having to do this whole horrible calculation all over again, that's the only difference here, is that because this is going to positive infinity, you don't get a negative sign right here, right? So that's the only difference. So essentially we did two examples in one, right? This example we're going to negative infinity, and in this example here, right, you're going to positive infinity. And the only difference is you lose the minus sign that we had from here. So I hope that helps. Again, if you have any questions, feel free to send me an email. But I think I'm going to leave it at this. This is probably the hardest example you're going to get. So I hope that does it for section 3.5.